Welcome everybody to another CanJS video. In this video, we're going to be going through a debugging tutorial showing how to use CanJS's powerful debugging tools in a wide variety of scenarios. For each exercise, we're going to have a problem be stated. Then I'm going to give you what you need to know to solve the problem. And then I'll show the solution. If you want to pause the video before I show the solution so you can try it yourself, please by all means try that. So this will be the pattern we follow for every step except for the setup one, which I'll just show the answer right away. All right, let's get it started. In this section, we're going to be setting up CanJS for debugging in two different environments. The first is with the MJS build. That is useful for code pens and anything else, and any module loader that can do tree shaking. And we're also going to be setting it up using the individual builds so that the debug tools are only loaded in development. So you're not wasting users' time by downloading stuff that they're not actually going to use. So the goal is in both of these environments to get this component working. And then we want to be able to see its view model in the CanJS view model inspector. So we want to be able to get this running and then be able to inspect its element and then actually see its view model and edit it. We also want to be able to see the debug utilities. We want to be able to go to the command line and write can debug and see those helpful utilities. So let's start with getting a code pen to work. And the first thing you need to do is install the CanJS dev tools. I've already installed it. It'll glow. It'll turn blue whenever it notices a CanJS page. It will turn blue anytime it notices a website that's using CanJS and has the debug tools installed. So to get this working in CodePen, all we need to do is create a new pen, and we're going to be using the MJS build. And we just need to import component from the unpackaged CDN. So here I'm going to import component from Can's core package, which comes with the debug tools already installed and invoked. And then once we have that, we just need to add the component code and the component tag. And then we can see the count element. You can see CanJS is glowing now. If we inspect that, we should be able to use CanJS's debugging tools. Now the first thing you'll notice is that CanJS's debugging tools aren't in their own tab. Instead, they're integrated into the tabs of Chrome's development tools. So here, when we're inspecting an element, we can actually see a CanJS view model tab that shows us the view model. So here we can see count. This allows us to see changes as we increment the count. We see it change down here. We can also edit the view model and apply those changes and see that the page has updated. Now we won't be showing much of CanJS's debugger tools in the actual Chrome debugger tool in this series of videos. Instead, what we will be focused on is the programmatic debugging tools. So here I can call can debug, and I want to make sure that that's available because we'll be using methods in there and other methods that let us inspect and see what's going on in CanJS. So there we've set up the debugging tools in the MJS build. Now let's see how to do it with Steel.js and the individual packages. Okay, so now that we've set up the MJS debugging tools, let's set up an example application with Steel.js and CanJS. And a Steel app that is using the individual packages instead of the single can module within the can package. So to start, I'm gonna make a new project. I'm gonna get that going and then explain what I just did. So I created a CanSteel project folder. I created a npm project within that. Then I'm going to install Steel, CanComponent, and CanDebug. I want CanDebug only to load in development, so I also need Steel Conditional, which lets Steel conditionally import packages or any module. So then we're going to set up the application with that. So what I'll need to do is to set up the app. What I need to do is add this integrate Steel Conditional into Steel.js. It's a super dependency. It needs to be there before Steel.js loads any modules. So I'm going to add this to my package.json to let Steel know, hey, you now are imbued with the power of Steel Conditional. Next, I'm going to set up a basic CanJS Steel application, essentially loading Steel. Okay, this is dev.html. Essentially, this loads Steel, then tells Steel load the main module, which is going to define this counter element and auto mount it. So that's going to be this index.js. Index.js is essentially going to be importing CanComponent, defining that component. And then also it's going to be importing CanDebug only if isDev returns true. So let's see how to make that happen. I can create this isDev module. And this is going to import Steel and essentially return Steel has its own environment, whether it knows it's in development or production. Here we're just going to return if we're not in production, we're in development. The index is essentially only importing CanDebug if isDev evaluates to true. I do want to check if type of debug is equal to undefined. Actually, if it's not undefined, then I actually want to run the debug function. This debug function is what registers this application with the debugging tools and also adds the can object to the window. So this is everything we need. I'll save all these files. I will open up I'll start HTTP server. Then I will open up the development page. And if everything went well, I can inspect this. And CanJS is glowing up here, and boom, we see the view model. So that's it. That's the setup. And I hope to see you at the next exercise.